During this segment, we will practice rationalizing denominators and numerators of radical expressions. Now, just what do we mean by rationalizing? It is sometimes advantageous to write a radical expression as an equivalent expression, but one without the radical in the numerator or sometimes the denominator. This process is called rationalizing. If we write it without a radical in the denominator, it's called rationalizing the denominator, and that's where we will begin. Here is a radical expression. I'd like to write this as an equivalent expression, but one without a radical in the denominator. So to do so, we will multiply by some form of 1 and then simplify so that the denominator no longer contains a radical. Now, do you realize that if I were to multiply the denominator by the square root of 7, don't forget that the square root of 7 times the square root of 7 is 7. Then the denominator would no longer contain a radical. I cannot do that in the denominator without also doing the exact same thing in the numerator, and here's why. I've written it this way on purpose. I'm going to multiply this radical expression by square root of 7 over square root of 7, because what does that simplify to? That expression that I'm showing simplifies to 1. And multiplying an expression by a form of 1 does not change the value of the expression. It makes it an equivalent expression. Most of the time I'll simply write it this way, but this time I wanted you to see that it is multiplying by a form of 1, not changing the value. Well, let's see what we have. In the denominator, square root of 7 times square root of 7 is 7. And in the numerator, square root of 2 times square root of 7, by the product rule, that is the square root of 2 times 7, or 14. Is there any simplifying that can be done? The answer is no. No perfect squares contained in 14 other than 1. And of course, I have just rewritten it so that I no longer have a radical in the denominator. Now, by the way, just in case you're thinking of this, if you're wondering, can I say, I don't know, divide out a common factor of 7? The answer is no, because this is 7, but this is the square root of 14. So you may not work with this radicand like that. I've rationalized the denominator. Let's try this again. Here's a radical expression. Let's look at a cube root. 4 over the cube root of 3. I'd like to write this as an equivalent expression, but one without a radical in the denominator. Now, be very, very careful. If you simply multiply numerator and denominator by the cube root of 3, now that's certainly an okay step. You will have an equivalent expression, but you will not have rationalized the denominator. This is a cube root, so what you'll have in the denominator is the cube root of 9, which can't be simplified. What do you need to multiply by in order to rationalize the denominator? You actually need 2 more factors of 3, which means you must multiply numerator and denominator by the cube root of 9. And you'll see what happens. If I do it in the denominator, I've got to do the exact same thing in the numerator. Now, in the numerator, I just have 4 times cube root of 9, or 4 cube root of 9. In the denominator, look what we have. We have the cube root of 27, and the cube root of 27 is 3. So I have now rationalized the denominator. Just be careful when you are working with cube roots. By the way, is there any simplifying that can be done? The answer is no. This is cube root, so there's no perfect cubes in this radical factor. Let's try this again. We are rationalizing. Let's suppose we have the expression 3 over the square root of 8x. It's really up to you, but I would suggest that if there's any simplifying that can be done, go ahead and simplify first, then worry about rationalizing. As long as you simplify, it will come out okay either way, but let's go ahead and just concentrate on simplifying. I see a factor of 4, a perfect square factor of 4 here in the 8, so this is the square root of 4 times the square root of 2x. You agree that 4 times 2x is 8x, and so I just use the product rule. So this is 3 over 2 square root of 2x. Now I'll concentrate on rationalizing the denominator. Since it's simplified, I know, and since it's square root, I know that I just need to multiply the denominator by the square root of 2x, and I'll do the exact same thing in the numerator, and then let's see what we have. In the numerator, I have 3 square root of 2x. What do we have in the denominator? Now this will be 2 times, and then the square root of 2x times the square root of 2x is 2x. So it's 2 times 2x, so this is 3 square root of 2x over 4x. And no, there's no dividing out of common factors or anything. This is outside the radical, this is inside the radical, so no, we cannot divide out anything in common. Here I have rationalized and simplified this expression, and I've rationalized the denominator. Let's now continue rationalizing the denominator, but let's now look at an example where the denominator contains what I'll call more than one term, in this case 2 terms. Now the expressions we looked at before, the denominator contained a single radical. This does contain a single radical, but we do have 2 terms here. How do we rationalize the denominator of this expression? Now, if you're thinking, well, I'll just multiply by the square root of x over the square root of x, you can do that, but the denominator will not be rationalized because this times the square root of x is certainly x, but this times the square root of x, you've now introduced it here. When the denominator is 2 terms such as this one, to rationalize this denominator, we will multiply by the conjugate. Now, in general, the conjugate of a minus b is a plus b, and the conjugate of a plus b is a minus b. So let's see what happens. We will now, trust me for the moment, and you'll see why, we will multiply numerator and denominator by the conjugate of the denominator. So the conjugate of the denominator is the square root of x plus 3. And of course, in the numerator, the exact same thing. Let's see what happens. Let's work on the denominator first. In the denominator, to multiply, we can think of the FOIL order. So let's do that. Square root of x times square root of x, that is x. And watch what happens when we multiply the outside terms and then we multiply the inside terms. The outside terms, this product is plus 3 square root of x. The inside terms, that's minus 3 square root of x. So these 2 terms, the O and the I in FOIL, they subtract out. And then we have last times last minus 9. And we no longer then have a radical in the denominator. Now in the numerator, we just have negative 7 times in parentheses square root of x plus 3. There's no simplifying that can be done here, so there's really in this case no need to multiply out in the numerator. So this is an appropriate answer. It is equivalent to the original expression, but the denominator is rationalized, or you can certainly multiply out in the numerator. Makes no difference. We're not simplifying any. In addition to this kind of rationalizing, it is also possible to rationalize the numerator of an expression. So let's look at an expression. This time, though, we will rationalize the numerator. Let's suppose we have the expression square root of 18 over 5. And my directions here are to rationalize the numerator. That means we want to write an expression equivalent to this one, but without a radical in the numerator this time. Now, I would still, whether we're working on rationalizing the denominator or the numerator, I would still use the quotient rule, split this up, and then simplify as much as possible. Let's do that first. So this is, by the quotient rule, the square root of 18 over the square root of 5. And then notice 18 contains a perfect square factor of 9. So 18, or the square root of 18, I can write as the square root of 9 times the square root of 2, and then of course in the denominator I do have the square root of 5. Now why did I do this? Because the square root of 9 is 3. So I have 3 times square root of 2 over square root of 5. If you are rationalizing the denominator, you multiply numerator and denominator by the square root of 5. I'm now, though, going to rationalize the numerator, so I will multiply numerator and denominator by the square root of 2. And then let's see what happens. Well, in the numerator, I'll have 3 times, what is the square root of 2 times the square root of 2? That is 2. So I'll have 3 times 2 in the numerator, which is 6. And in the denominator, I have square root of 5 times square root of 2, which is square root of 10. Notice I have rationalized the numerator. No more radical in the numerator. This is equivalent to the original expression. Is there any simplifying that can be done? The answer is no. 10 contains no perfect square factors, so no simplifying in the denominator, and I may not look for common factors in the 6 and the 10 because this 6 is just a whole number 6, and this is the square root of 10. So don't look for common factors there. The numerator is rationalized, and there is my simplified answer. At this time, practice rationalizing numerators and denominators of radical expressions. Let's see how you are doing with rationalizing denominators by answering the following question. To rationalize the denominator of cube root of 7 over cube root of 5, multiply by what form of 1? Do you multiply by the cube root of 5 over cube root of 5? Do you multiply by choice B, cube root of 7 over cube root of 7? Or do you multiply by choice C, cube root of 25 over cube root of 25? The video will pause, then make your selection. Unfortunately, A is not the correct choice, although it's perfectly okay to multiply this expression by this one. Notice in the denominator you would have the cube root of 5 times 5 or the cube root of 25. That will not rationalize the denominator. You need to multiply by choice C, cube root of 25 over cube root of 25. Choice C is the correct answer. B is not the correct answer, although it is mathematically okay to multiply this expression by this because this is 1. What you'd have is the cube root of 49 over the cube root of 35, and that will not help you rationalize the denominator of this expression. To rationalize the denominator of that expression, You need to multiply numerator and denominator by cube root of 25, because in the denominator you would then have the cube root of 125. That's a perfect cube, and that simplifies to 5. So choice C is the correct choice. Choice C is correct. Let's make sure you understand why. This is, of course, a form of 1, and in the denominator, we would have cube root of 5 times 25, which is cube root of 125. That is a perfect cube and simplifies to 5. So choice C is correct.